All right, so I'm good to start. Hey everyone, thanks for having me. All right, this is a little bit weird because I can't see you guys and I'm not there. So I'm just gonna try and pretend that I don't know, a radio jockey or something, which funnily enough, I used to be. So hopefully you guys can all see the screen all right. This is the interface for an application that I built called DSpectrum GUI. I just call it DSpectrum, which is a little bit confusing because it was initially a command line only tool. That tool had some limitations though. And those limitations could only really be addressed by putting a nice front end around it. So I'm going to give you guys a little bit of a run through on how this works. All right, so the first thing that we'll need to do once we've got everything up and running is create a new device. So I'm just going to call this wireless alarm system. All right, we don't need to worry about the bits of information that we don't know yet. So for example, the FCC ID, which I don't have, the modulation type and encoding, but we will put in the frequency because we know what that is at the moment. All right, that's about it. So I'm gonna hit submit. Now this is a little bit tricky. So when you've created a device, it's best to think about a device as sort of a category of devices. So in this instance, we'll have several different remotes. So I'm just labeling the device as a wireless alarm system. And down here, where it says units, that's where you put the individual instances of devices. So one of the remotes that I have is blue, the other one's silver. They both belong to the same product. So I'm just going to create one unit for each of those remotes. Once we've got that, navigate to one of the units. And you can see that there's really nothing going on here at the moment. So we need to add new capture. So we'll just click that button. And what this has done is it's executed the batch command in Spectrum to open that application up. So all we need to do is navigate to our file. I've already got some captures here that we're going to use. So I like to name things like this very specifically so that I can remember what they are. The way that I do that is I give each remote a name. If they're identical, then I might put a little post-it or something on them so I can tell them apart, maybe with a number or something. And I make sure to note which button was pressed. These captures were taken with Osmocom, which is just a an application based on GNU Radio Companion. And what that sort of does when you save a file by default, it'll add some information in there. So it's got the frequency, it's got the sample rate, and it's got the time that the capture was taken. I like to leave that information in there and just sort of prefix whatever else I'd like to in the file names. So we'll start with the blue remote, and we'll start with the lock command, which is called arm here. So once we've got this open up in Spectrum, you should ordinarily, you'll see more than this, but in Spectrum's remembering my last settings where I've changed the power minimum value, which just obscures the weaker parts of the signals from view. So I'm just going to set that back to roughly what it would be if you're opening it for the first time. We just need to scroll along until we see something interesting. All right, so I don't know what these are at the beginning. I think it's just partially captured one packet. But what you should see, I'll just zoom out a bit. That's as far as I can zoom out. All right, so you should see that the same packet is repeated multiple times. This is pretty standard for a lot of sorts of devices like these. And the reason for it is because if there's any sort of interference around the signal, it sends it in a burst so that hopefully at least one of those will go through fine. So we'll just pick any one of these and try and sort of make it fit the screen as snugly as possible. And I'm going to change the power min slider a little bit more so that we're just left with a clean representation of the signal that we care about and none of the background noise. If it's green or greenish, then you've done a good job at that. Now what we're going to do is we're going to put a sort of grid overlay on top of these signals. When in doubt, I just start with the number 5 out of habit. So we get this little grid that pops up, and we can sort of drag the edges to adjust the size of it. So I'm going to drag this over to the start of the first symbol. And we're going to try and neatly encapsulate this smaller size pulse. So we'll see in this file, we've got pulses of 2 different lengths. So we've got these really short ones, and we've got the longer ones. So I'm going to pick the shorter symbol, and I'm going to make that symbol, or that pulse rather, perfectly fit into one of these little cells here. And then once you've done that, we can just keep hitting the up button here to sort of increment and add new cells as we go along. Now you'll notice that more than likely these will start sort of getting out of sync as you keep pressing them. So we can see that this line here doesn't neatly start at that pulse. So we'll just drag that slightly to make sure it all lines up perfectly. You might have to do that a couple of times as you go on. So it's starting to drift again. We'll just fix it up. And we're going to rinse and repeat that until we've covered the whole packet. All right. So once we've done that, we just right-click anywhere in this area and select Add Derived Plot, Add Amplitude Plot. And that brings this. So we can manipulate this in a couple of different ways. If we want to move the whole bar, then we drag the red line. So we're just going to drag this down so that we sort of get it roughly on top of these pulses. We can see now, we can see the waveform at the bottom of the screen. I find that it's pretty good practice to make that as small as you can, just to minimize the background noise. Once we've got this, we can right-click this area right on top of these waves and press the button Extract Symbols to Standard Out. Once we've done that, DSpectrum will shut down. DSpectrum has captured the information from that because it started the application and has access to standard out. Then we can just give it a file name. So that was the lock command, which I've been calling ARM because it's an alarm system. So I'm just going to give it a meaningful name here so that we can tell it apart later. Now that that's there, we're sent back to this page. So now there's a little bit more going on. We can see down here, if we scroll a little bit further, it's automatically figured out that the encoding type is PWM, which is pulse width modulation, and that it's a 7525 format. So that means that with those little pulses that we saw, if we interpret a grid, and I'll repeat this again later on when DSpectrum's open, but if we interpret a grid with a pulse in it, or a cell with a pulse in it, as a 1, and a cell with nothing in it as a 0, then 1, 0, 0, 0 would be expressed as a 0 in PWM, and 1110 would be expressed as a 1. So it's automatically done that decoding for us, and it's popped the binary right here. And it also gives us the hex and ASCII translations in case that's a value. Sometimes it is and sometimes it isn't, but I personally found it handy to sort of keep that in there. The other thing we'll notice is that while it was checking that it was valid, it detected that there was an issue. So we stopped at the last pulse when we were aligning that grid, but technically it should have been 1, 0, 0, 0. So the application's picked up on that for us. And if we refresh the page, actually gone ahead and fixed it. So now that we've got that, let's scroll up again and go back to the device. Oh, wait, actually, no, we want it to be there. Sorry, we'll go back to blue because we've got another capture to add. So we'll go and add that in. All right, so last time we did ARM, this time we're going to do disarm. So scroll across one of these packets, get it perfectly in the screen, and then we can go ahead and do this process again. It gets a little bit tedious, but this is the least tedious approach I found to extracting these symbols so far. By the way, if anyone has any questions, because I can't see you guys, if you could just let Pam know and she could send me a message or just call out if the mic's on, then that'd be awesome. I don't mind being interrupted. It's totally fine. Oh, whoops. All right, something's gone very wrong here. So I've made a mistake. I'm just going to start again. There you go. It's a little bit better. All right. All right. So this is how we captured it last time. And we'll see here where there was a short pulse followed by a long gap. There were exactly 3 cells. If we have a look at all of the other ones, it's consistent throughout it. So that's why DSpectrum picked up that there was what it refers to as significant white space at the end that we missed out on. It did fix the last one for us, so we technically don't have to do this, but I will anyway. I'm just going to add 3 effectively zeros at the end of that to make it valid. I'm going to go ahead and do the amplitude plot again. And then extract the symbols. All right. So now this one should have already been picked up as valid, and it was. So that's fantastic. Now we can see already by having a look at this tool that there are 4 bits in this particular capture that were different from the others. We'll come back to that in a bit more detail in a moment. Go back to the device and go to silver, and we'll add these captures real quick as well. All right. I'm just going to cheat a little because I've done this a lot of times for these captures and happen to know exactly how many there are. Oh, that was whoops. All right. Cool, and we'll add the last one. For the right. Yep, it's being picked up as PWM, so that's great. So now we can head back to the device view, and what we get here is we just get a little bit of an overview of those bits in the same way that we did when we were looking at the page for an individual unit, except now it's showing all captures across all units. But the bit that we're going to find most useful is if we scroll up a little and click on the view reversing worksheet button. That's going to take us to a page that looks very similar, except now we have a few different options. So we can import sections from a library. I'm hoping, I'll talk a bit more about this in a moment, actually. But we can also manually define sections that are of interest to us. What tends to work for me is dividing, separating these by blocks of 8 bits or a byte. So let's start off with doing that and then see if we can make any sort of observations about that data. So I'm just going to call them unknowns because they are at the moment. All right, so we can see now that we've just got a little bit of color here and we've got a section for our notes over here. So I'm just going to rinse and repeat that for the remaining bits. Actually, I might give that a color. All right. And 16 to 23 would be the next 8. All right, we've got another one at the end. So we've gone in sets of 8, and we found that there's an extra one at the end. So for the moment, we'll just leave that in its own category and see if that works out for us. If it doesn't, then we can always come back and change it later. That's 24. Okay. Cool. All right. So let's take a look at this. So at the moment, we can see that we've got our capture names here, as well as the names of the units that they belong to. So we've got arm, disarm, and disarm. First thing we're going to do is have a look and see if anything changes when a different button's pressed. So I can see here at a glance, and we're looking at the red section, that for the top one, it differs a little bit from the bottom one. The third one looks exactly the same as the one on top, and this one looks exactly like the one that's in the second row. So we can already, from this, make an assumption that this section could be the function. So that's red. We're just going to jump back up here real quick and edit our notes. Okay, great. So having a look at the 2 other sections that we've got, so the gray one and the blue one, we can see that the bottom 2 rows are identical compared to each other. We can see that the top 2 rows are identical compared to each other. And if we go back and have a look at what the captures are, we can see that between the 2 blue captures, they're identical. Between the 2 silver remote captures are identical. So we can make the assumption, therefore, that this is probably some sort of a device ID that differentiates between the actual units. So I guess that you could probably consider that to be a very weak form of authentication, or I guess identification is more appropriate. But we're going to go ahead and change those. So if they both mean the same thing, then we can get rid of one of these definitions. So we'll just delete that one. And we'll edit this one so that it encompasses both. So we'll go from 0 to 15, which is the first 16 bits or 2 bytes. And give it a color as well. I like to leave grays for sections that I don't know the purpose of. We'll give this one a name. So for the moment, this has always been 0. So I've just decided to assume that this is some sort of a packet terminator or something like that. So just going to edit it to name. Did I spell that right? That should have been an E. All right, anyway. So that's pretty much how this sort of works. If we didn't want to do this and we wanted to see whether someone else in the community had already, sort of reversed this device and contributed their template, then we could do a little bit of Googling, have a look at the GitHub page and check that out. But I've already got that one in here saved as a template. So I'm just going to show you guys how that works real quick. It's the only one currently in this application, but I'm hoping that the community sort of creates some and publishes some so that I can add these in here. But for the moment, we'll just try it out with this. So I've just selected it from the dropdown. It happens to be the only one that's in here anyway. And we just click this add button. And it all sort of pops up here. So this is one that I, sort of prepared earlier. I've added a few extra notes. But yeah, that's basically it in a nutshell. What we can then do if we want to is say we wanted to, all right, let's imagine for a moment that the blue remote belonged to a wireless alarm system at my house, and the silver remote belongs to a wireless alarm system that was installed at my friend's house. Now, let's say that I wanted to impersonate his device without, just doing a replay attack. So this would come in handy if you were doing something more complicated, or if I only had access to the function and didn't want to wait 10 hours for him to come home again so that I could get the unlock code. What I could do then is pick and choose, and this All right, so just remember that we've created these 3 sections up here. So that's where these form elements come from. So I can then pick the device ID, which is the section that I've labeled, and decide that I want that to come from blue. Actually, no, silver. Sorry, we're doing silver. So picking that from silver arm, I'll pick the disarm code from blue. The packet terminator is always the same, so that doesn't really matter. But when I click on this button, it's going to sort of take the relevant bits from each section and automatically put them into a format that RFCat can understand. So if you have a yardstick 1 or some other device that plays well with RFCat, then the code for you to sort of generate this is already there. What it's currently missing, though, is the baud rate, because we didn't go ahead and change that. But we can update that in the device view and then come back to this page, and everything that we need to transmit the signal will be sitting here and waiting for us. So I'll show you guys how to get the baud rate, just in case you don't already know. So let's go back to where we spawned in Spectrum. Or we can do it manually, but I find that this is a bit easier now. So we'll just open one of these up again and act as though we're taking the capture. Okay. Now, here in Spectrum, when we've got the grid perfectly aligned with as many symbols as we can, we start to get a reasonably accurate baud rate. So in Spectrum actually expresses this as a symbol rate. So this is the value that we're interested in, but we need to shift the decimal place over 3 spots. So instead of this being 2.21259 kilohertz, we're going to interpret that as 2000. Well, technically 2212, because we're going to shift the decimal point over to here. So 2215. Whoops. All right, now if we go back to the reversing worksheet and generate the binary again, we'll see that it's now setting the baud rate correctly. So as this currently is, that's perfect. If you're curious about what this line here does, when it's set to a 0, and DSpectrum will always do this by default because it doesn't know whether or not you want to be transmitting a preamble. When this is set to 0, it's instructing RFCat to not send a preamble along with the signal. If it did that, then the code that we were transmitting wouldn't work because this particular alarm system doesn't expect to receive that, and it would just be sort of seen as garbage, and it would make the rest of the packets that we're transmitting invalid. All right, so the other thing that we can do here, if the manufacturer of the device actually intended for PWM to be interpreted in reverse, so if this was a 1 and this was a 0, then the information that we get from Spectrum would be wrong. So this doesn't matter for the vast majority of devices where the data being sent isn't meaningful, or at least not translatable to anything a human could make sense of. But sometimes signals are. So for an example of that would be I reverse engineered a weather station a little while ago. So all it does is it's got some sensors that you can place in the backyard, and it'll transmit to its base station what the humidity and the temperature is at that particular location and report back. So in capturing that information, it's not just a sort of random binary string that another computer is expecting to trigger some sort of function or event. It's actually sending data. It's sending that temperature and that humidity value. So in that case, whether or not this is a 1 or a 0 actually becomes really significant. If DSpectrum gets that wrong, then you can always click on Edit Device and tick this box, which is just called Flip Decoding Assumption. And basically, that's just going to turn the 1s into 0s and the 0s into 1s across every capture that it's done for this device. So now instead of being 0, 1, it starts with 1, 0, and it's flipped each and every one of those. That's pretty much it in a nutshell. What I'm hoping to sort of see from the community that use this application is that people will start adding to those templates. So if you did want to contribute something to them, it's reasonably easy to do that. We go back to the reversing worksheet. And then all the way down at the bottom, there's a little form that you can sort of fill out. So let's fill this out and pretend this is a fresh, unique template that we wanted to share. We know that it's not already in the library already. We'll just give it a name. And you can put your handle in here if you want, and we will attribute you as the author of this particular template, but you don't have to share that if you don't want to. And you click on that button. It gives you a little bit of code in a block, and it gives you some instructions. Basically, I've decided that the easiest approach to this would be for people to create issues in GitHub. The alternative was for people to commit a changed file to their local copy of the repository and then submit a pull request. But I thought that might be unnecessarily complex, especially for users who maybe aren't really familiar with managing repositories via Git. I still wanted them to, feel like they were able to share their work. So I thought that this would be the easiest way. So what we would do then is go to this link, go to issues, click on new issue. I'm not logged in. All right, give me a sec. All right. Go to issues, click on create new issue. And then here, all we need to do is copy this and put it in here. And ideally, throw in a title that's easy for me to recognize. So if you just copied and pasted this whole thing, that'd be great. And then you can just replace this with whatever name you wanted to call it. So using the name you gave the template would probably be a good bet. That's it, just hit submit. And then when I see these in there, I'll do my best to sort of incorporate them into the seed file of the application so that other people can benefit from that as well. Then once it's in there, if you wanted to use it, you could just do what we did earlier, which was select it from the drop-down box at the top. That only appears if there are no currently defined sections. We've got some sections that have been defined in here, so that form won't show up. That's pretty much it in a nutshell. Does anyone have any questions or want me to sort of go over anything in greater detail? All right, I'm going to take that as a no. All right, sweet. Well, thank you very much for having me, guys.
Trey, can you hear us now?
Yes, I can hear you now.
Cool. Thanks for the demo. It was really good.
Oh, you're welcome. Thank you.
Does anybody have any questions in the room?
When you got the output from InSpectrum,
yep.
Did it report that error about the length of the last field not being right, or does your program work that out?
My program works that out. It's some pretty rudimentary logic that's in there to try and make that happen. But basically, the way that it's doing it, just for anyone who's curious, is it's I've got actually I might be able to show you guys the actual code if you want. But basically, what it's doing is it's taking the raw binary which is these. And it's stripping off the last couple of characters. Once it's done that, if that last character is a 1 and not a 0, and it knows that the whole rest of the packet would be valid for that modulation type if there were a couple of zeros sitting in there, then it'll let you know that. And it actually does the same for another type of modulation, Manchester, which isn't showing up in here. Let's go back to the devices page. Sorry, the units page. Forgive me, I get a little confused with this because I spent so much time writing code for it. In here, where it's trying to work out if it's Manchester encoding, it'll do the same thing as well. So in this case, if it finds that everything would be valid if it started with a 0 and sort of pushed the alignment out, but that 0 isn't present, then it'll give you a warning for that as well. So it does try and help you out a little bit with things like that. In some cases, it suspects that it might be right in thinking that you've incorrectly taken a capture, but it's not confident in its ability to fix that without compromising, the sort of resulting binary. It will actually just tell you that it thinks that it might be wrong, but it won't fix it for you. So it's a good thing to just sort of keep an eye on this field and read it carefully, because in some cases it will automatically try and make that change, and in some cases it won't.
Okay, thank you.
Okay, cool. Any other questions? We're all good, Trey. Thank you for that.
Oh, you're very welcome. Thanks again for having me, guys. Hope you're all drinking beer.
What was the brand of the weather station? Was that the JCar one that you were reverse engineering?
The weather station actually doesn't have a discernible brand. My sister works at Australia Post, and it happened to be a product that we're selling for a little while. She saw that it said MHZ on the box, decided to buy it and brought it to me and said, "You like stuff with MHZ on it, don't you?" So that's how I ended up with it. I think it was probably, I think it was selling for about, I think $40 or so from memory. I can post a picture of it later on if you guys are interested. Funnily enough, that was actually the most complicated device that I've reverse engineered so far. It was very tricky. It took a lot of trial and error, and I was pulling my hair out for ages, but it was really satisfying to finally figure out how it was transmitting that data. So I would highly recommend grabbing one if you feel like you're getting a bit bored with maybe doing things like reverse engineering doorbells and things like that.
Yeah.
It's definitely challenging.
I have the JCar one, and it's killing me trying to
Yeah?
decode.
Oh, you need DSpectrum.
Even Ash has tried it; he can't decode it.
Ah, interesting. Well, hey, if you're able to put some C files somewhere for me, I'd like to take a crack at it if you don't mind.
Cool. Yeah, we worked out it's Manchester, but it seems to pack all the data together.
Interesting. Yeah, okay. Yeah, I'd really like to see it if that's all right. It'd be awesome. Maybe we can work together.
Cool. Thanks, Trey.
Cheers. All right, so
We'll
any more
sign off.
questions?
I think that's it.
All right, awesome. Have a great night, guys.
Cheers.